Silicon carbon batteries, the breakthrough that will revolutionize EVs in 2026. 1. The problem with current batteries. For decades, lithium-ion batteries have powered everything from our smartphones and laptops to electric vehicles and grid-scale energy storage systems. But there's a fundamental limitation that has held back the technology for years: graphite anodes can only store so much lithium. That cap has kept EV range stuck around 300 to 400 miles per charge, and charging times frustratingly slow compared to filling up a gas tank at a fuel station. Now, a breakthrough technology is changing everything and turning the battery industry on its head. Silicon carbon batteries are here, and they promise to double energy density, slash charging times to just minutes instead of hours, and make electric vehicles truly competitive with gasoline-powered cars on every single metric that matters most to consumers. 2. Why silicon is the answer. The secret to this breakthrough is in the anode, the negative electrode inside the battery where lithium ions are stored during the charging process. Traditional lithium-ion batteries use graphite to store lithium ions, but graphite has a strict theoretical capacity limit that engineers have been bumping up against for years. Silicon, on the other hand, can store up to 10 times more lithium per unit of weight than graphite ever could. The problem has always been that silicon expands dramatically during the charging process, sometimes expanding by as much as 300% of its original volume. This massive expansion causes the silicon to crack and degrade after just a few charge cycles, making it completely impractical for real-world use in consumer products. That's where the carbon part of silicon carbon batteries comes in. By combining silicon with carbon nanostructures in precise engineering configurations, researchers have created anodes that can expand and contract dramatically without cracking or falling apart. The carbon acts as a flexible scaffold, holding the silicon together even as it swells and shrinks during repeated charge cycles. The result is a battery that holds significantly more energy and lasts for hundreds of charge cycles, finally making it viable for consumer products like electric vehicles and portable electronics. 3. The breakthrough in 2026. In 2026, we are seeing the first large-scale deployment of silicon carbon batteries in production electric vehicles from major automakers. Companies like Group 14 Technologies and Sila Nanotechnologies have built manufacturing facilities capable of producing silicon anode material at commercial scale for the first time in history. Group 14's SCC-55 material is already being used in the Mercedes-AMG GT 4-door coupe, which achieves 298 watt-hours per kilogram at the cell level. That translates to 600 kilowatt charging speeds and the ability to go from 10% to 80% charge in just 11 minutes, making it the fastest charging Western carmaker vehicle ever produced and a true game-changer for EV adoption worldwide. Meanwhile, Sila Nanotechnologies has started construction on a massive manufacturing facility in Moses Lake, Washington, designed to produce silicon carbon materials for electric vehicle batteries on a full commercial scale. This development marks a critical step toward mass adoption, as Sila aims to supply next-generation anode materials to major automotive OEMs around the world. 4. What this means for EV owners and consumers. The practical impact of silicon carbon batteries on consumers is enormous and immediate. EVs equipped with these next-generation batteries will offer at least 50% more range than current models, potentially pushing the range beyond 500 miles on a single charge and eliminating range anxiety forever. Charging times will drop to levels comparable to filling a gas tank, eliminating one of the biggest barriers to EV adoption that has held back the industry for years. And because silicon is abundant, cheap, and environmentally friendly compared to cobalt and other rare materials, the cost per kilowatt-hour should continue to fall as production scales up and manufacturing becomes more efficient. Chinese manufacturers have already been using silicon carbon anodes in smartphones for over 2 years now, quietly revolutionizing the mobile device market. The OnePlus 15 and other flagship devices feature batteries that last significantly longer than their predecessors, thanks to this technology. In fact, silicon carbon batteries have been powering Chinese consumer electronics since 2024, and the technology is now finally making its way into Western markets and products. 5. The global race for battery dominance. Tesla has also entered the silicon battery race, publishing a patent in late 2025 for a method of producing silicon composite anode materials using dry electrode processing. This dry electrode technique could give Tesla a significant manufacturing advantage, as it eliminates the need for toxic solvents used in traditional electrode production and reduces both costs and environmental impact. The global silicon-carbon battery market is projected to grow from just over $1 billion in 2026 to more than $15 billion by 2034, representing a massive opportunity for investors and manufacturers alike. Every major automaker, including BMW, Toyota, and General Motors, is investing heavily in this technology and racing to bring silicon-carbon battery vehicles to market. Battery manufacturers are scrambling to secure silicon supply chains and build the specialized factories needed to meet the enormous anticipated demand from the auto industry. 6. The challenges that remain. Despite the impressive and genuinely groundbreaking breakthroughs, there are still significant hurdles that need to be overcome before silicon-carbon batteries become the industry standard. Manufacturing silicon anodes at scale remains expensive, and the production process requires extremely precise control over nanostructure and material composition. Yield rates are still improving, and not all manufacturing methods produce consistent, high-quality results. There's also the question of supply chain reliability and geopolitical risk. High-purity silicon and specialized carbon materials need to be sourced from multiple suppliers around the world, and geopolitical tensions could disrupt access to these critical materials at any time. But with multiple companies racing to solve these problems simultaneously and investing billions of dollars in research and development, solutions are coming faster than many industry analysts initially expected. 7. The big picture and outlook. Silicon-carbon batteries represent far more than just an incremental improvement in battery technology. They represent a genuine paradigm shift in how we think about energy storage and the future of transportation. Combined with the rapid expansion of AI data centers and the growing demand for grid-scale energy storage solutions to support renewable energy, this technology will shape the next decade of clean energy, electric mobility, and sustainable living for billions of people worldwide. The question is no longer whether silicon-carbon batteries will dominate the market and replace traditional lithium-ion technology. The question is how quickly they can scale to meet the enormous demand that is already building from automakers, consumers, and energy companies around the world. For the millions of EV drivers and potential buyers out there, the answer can't come soon enough. If you found this video informative, please like and subscribe for more science and technology coverage. Drop a comment below with your thoughts on EV battery technology and whether you'd switch to an EV with a 500-mile range and 10-minute charging. And share this video with anyone interested in the future of electric vehicles, clean energy, and sustainable transportation.